And we have to finish up chapter 4 today. Basically, every three times class meets, we're going to have covered 2 chapters. And I'm going to keep showing videos and trying to help you understand what they're talking about here. But I don't talk about the assignments. They're all on Canvas. If you don't understand what to do, if you don't do the assignments, you get zeros. And even if you come to class, you could still fail the class. So you want to get all those assignments done, because that's the basis for earning a grade. Coming to class is what lets you earn the grade, but doing all that work is what earns the grade. So look at Canvas, look at those assignments. If you don't understand something, write me an email. But I think over the weekend, I put a bunch of zeros in for people who didn't have stuff done by the deadline. Now, it doesn't mean you can't do it, but the grade will be dropped because you have turned it in late. So get that work done, and if you have questions, send me an email and I'll help you work through it. We're on page 129. Yes?
When you say to do internet research on here, does that mean you want us to research the chapter, the rest of the assignments for that day are on, or research the entire book?
Oh, internet research is for each chapter.
Okay.
So that just means that for this chapter on this stuff here, you just go look at something on the internet that relates to this chapter and write up what you learned from looking at stuff on the internet. And you're welcome to use some of the stuff that I bring up here in class, and you're welcome to use stuff that I have on my Twitter account. Have any of you been checking out my Twitter account? CBC Geography. I keep adding new stuff that's so cool all the time. At least I think it's cool. So we're on page 129. And I'm assuming that all of you have studied the carbon and oxygen cycles someplace in life. Probably you studied it in science class somewhere earlier in life, where, remember those photosynthesis, it says on page 129, can be shown by the following equation. Carbon dioxide plus water plus energy produces carbohydrates and oxygen. And then the carbohydrates plus oxygen produces carbon dioxide and water plus energy. You've seen those equations somewhere before. Probably the cycle is that photosynthesis. What a wonderful word. If I could make a photosynthesis machine, think about it. I would just plug it into the wall and dial it over to say, let's see, I would like to have some oranges for breakfast. So I dial it over to oranges, and then the photosynthesis machine just blump, 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 pops some oranges out of the machine. And then I'm going, I'd like to have some bananas on my Cheerios, so I'll turn it over to bananas, and blump, 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 some bananas would just pop out of my little machine. And when I said plug it into the wall, no, if it's a photosynthesis machine that works like photosynthesis does, I mean, where do the oranges come from? A tree that soaks up water and takes in sunlight. So I would just have my machine sitting in the sunlight, hooked up to a water hose, you understand why it's called photosynthesis? Because the process, got you, Christina, the process is so complex. Scientists, they know what's going on, but they can't replicate it. It's a beautiful process that God has put in place. I mean, think about it. if you live someplace where you could have an orchard with trees for any kind of fruit you wanted, that sunlight shines on a tree, the tree soaks up water from the ground, puts on little buds that turn into little flowers, that turn into little fruits, that grow and develop, and then we watch them get ripe on the tree, and then we pick them. Have any of you ever picked fresh fruits from a tree? You just pull it off of there and eat it, and it's delicious. And every kind of tree makes its own kind of fruit, and it's an amazing, I'm going to even say a miraculous process where water and sunshine and a few trace chemicals from the earth produce all these beautiful fruits and vegetables that we eat, all the things that come from plants. And then while the plants are doing that, we talked about that last week, while the plants are doing that, they're soaking up the carbon dioxide that we've exhaled, and they're producing oxygen for us to breathe. I mean, to me, it's just a marvelous process. And then we eat the fruit, and then for some of the vegetables, do any of you eat tomato leaves? I don't think so. We just take the fruit off of tomatoes, don't we? But carrots, you pull a carrot out of the ground, do you eat the carrot and then take the stuff off the top and make something out of it? Use carrot tops for salads? But you kind of do with cabbage, don't you? And lettuce and stuff like that. So it's just a matter of God has created all of these plants, and then created this process for the plants to reproduce, and we get to enjoy the benefit of it. And then we get to consume what the plants produce and give off carbon dioxide, and they take our carbon dioxide and with photosynthesis turn it into, and that water turn it into these fruits and vegetables, and we get to consume them. Okay, on page 131, it talks about soils. Actually, it starts talking about them on page 132. And probably the thing when you look at this, on page 133 it says thousands of soils. And one of the reasons I put the globes out today is so we can look at these. But probably before we do that, we should maybe look at what soils look like. Now, see, there's a picture on page 133. There's the horizon, the organic matter up there, which some people call topsoil. Why would they call it topsoil? Because it's at the top of the soil. Have any of you ever gone to a store and bought some soil? You bought some stuff to put plants in to make them grow. You bought a sack of it. You opened it up. And did it smell good? Or you didn't smell it? When you touched it, did it feel good? You put it together. It's rich plant matter. It's stuff that they've made. You probably don't know what they used to make it. But do any of you have a compost pile at your house? Where you throw leaves and debris in there and add stuff to it, and you just let nature do its thing. You let the bacteria in the soil and the earthworms work on it and turn it into soil that you can use to raise crops. But just like the atmosphere is very thin, that keeps us alive and makes this whole system work, so the soil layer at the top is very thin too, because soil, the topsoil can wash away, and the stuff that's left underneath is not very good for raising crops. So that's why they show this picture of soil. But I found some stuff here. Let's see if it's going to let me do a little looking up here for some stuff. What did I call this? Soil horizons diagrams. And for doing internet research, you can just do that. You could just Google soil formation and see what you find. I'm not going to Google everything because there's not time to do it, but I'll take soil horizons and diagrams. S-O-I-L. Where did it go? I don't know. Let's do it again. S-O-I-L-H-O-R-I-Z-O. Horizons diagram. There it is.
Dr. Bonin?
Uh-huh. Oh, thank you. Have to turn that on, don't I? Soil horizon diagrams. And here's a whole bunch of diagrams. Here's one that kind of looks like the one in the book. The surface layer, organic debris, topsoil, subsoil, parent material, bedrock. Let's look at another one. Topsoil, transition, subsoil, and C. What was that called? Bedrock. O, organic matter. See how they, oh, and by the way, while you're looking at this picture, I don't know if you can see it or not, but can you see how far the roots from these plants go down? There's, okay, have any of you ever dug up some grass from out in your yard? I mean, dig way down in the ground till you get clear below the roots and shake the dirt off of it and see how long the roots are on your grass? Okay, most of the grass that we grow in our yards will have root systems that go down about this far. The grass that in the Great Plains area, the grass that the native grasses that grew there before we settled it and plowed it up and started raising crops, the grass in the Great Plains area will have a root system that sometimes goes down as much as 15 to 20 feet below the surface. And by the way, think about this. If grass has a root system that goes that deep to find water, what do you think happens during a drought? You see how the grass can still survive the drought? Because it's going deeper to find the water. Whereas our yards are just very shallow with their root system. So when we have a drought, it doesn't take much at all for the yard to dry out and go dormant and quit being productive. But God's grasslands around the world have such a deep root system that even during droughts, it keeps growing to feed the livestock and animals that graze on it. Here's another one, soil layers, humus, topsoil, organic layer, humus, alluvial layer, topsoil. See, they give all these different names to it. Don't let the words in this book scare you. Just say, okay, they just have all these fancy words to label things, but I'm going to learn to look through it and understand what's going on. There's just a lot of pictures of it that you can look at to get a picture in your mind of what's going on with these various soil types. Okay, that's enough of that for now. So you basically take that picture from page 133 and say, okay, I can see a whole bunch of other pictures that are similar to it that help me get a picture of what's going on. But when they talk about thousands of soils, page 134 and 135 show a picture, and that's why I put these little globes out here today. No, somebody doesn't have one back there. We can't have that. Everybody should have a globe. Here you go. Okay. Because I want you to look at, when you look at this map, and when you look at these soils in this picture on page 134 and 135, well, let's just Google something here. Turn this back on. While you're looking at that, go ahead and look at your globe. Now what happened? There. Go ahead and look at the pictures on page 134 and 135 and look at your globe to see where some of that soil is. And I'm going to find something here. Well, I thought I was. Okay, let's go back. Nothing wants to work for me, just like that's okay. I'm going to keep working at it. What did I say? Types of soil and their uses. And there it is. So see, when I'm at home, while you're out having fun, I'm doing geography research because that's what I do for fun. So when I find this stuff, you might want to write some of these down as places to go to look for things. What did I say? Types of soil and their uses. What I liked about this particular site was that it not only shows the types of soil, but it talks about what they're used for. Now, which one was it? Let's see if this is it. Yep, this is the one. And look what somebody wrote. Too long, I didn't read it. And I say, too bad for you. You missed out on a lot of valuable information.
At least they were honest about it.
The 12 scientific... Have you heard that little joke about the two greatest problems in the world?
No.
You go, I don't know and I don't care. Ignorance and apathy. Got it? I don't know, ignorance, apathy, I don't care. Okay, enough of that. Let's get back. You know, if you teach geography, you're not supposed to be funny. You're just supposed to teach geography. The 12 scientific soil orders. And see, I think, here's what I like about that. That's this scientific stuff. I mean, when you look at page 134 and 135, you go, somebody had way too much time on their hands to go around the world categorizing all the soils in all of the in all the continents. But what I thought's good about having your globe, just like, take the first one there because it's bright red and it's a fun color to look at, and it's called what? Oxy soil. And kind of look at where you find it, and then look at your globe to see where it is in terms of on the planet, and that helps you kind of understand what's going on here. Where's andisoils on there? Do you see it? You see andisoil is the second one after oxysoil. See where andisoil is? There's a lot of that. Look what this says about andisoil. It forms in volcanic ash or debris from a volcano. The properties include the ability to retain water, and that would be valuable for plants, and remove large amounts of phosphorus to keep them from plants. Oxysoils represent highly weathered soils rich in iron and aluminum oxide. That's why they used red, because it has that iron. Have you ever been someplace where the water had a lot of iron in it? You go to Michigan where they do iron mining and you pump water out of a well and wash your hair, and if your hair is light colored, after you took a shower and washed your hair is now light red colored because of the iron ore in the water. So you need to know some of this just to know don't wash your hair with that water. When amended with lime and fertilizer, plants can thrive there, but that's why where you find oxosoil, they have to use a lot of lime and fertilizer. Where you find andisoil, they've already got a lot of the nutrients there. Vertisoils are rich with clay. They swell with moisture and shrink when they're dry. And potters use clay to form earthenware, porcelain, and other kitchenware. And when amended and irrigated properly, some plants thrive in them. Now, do you know what they mean when they say when amended? Okay, I have a lot of clay in the soil at my house. So if I decide I want to plant a garden and I take a sample of my soil to the county office where they analyze soil, here's what they will say. Your soil has so much clay in it, you need to buy some bags of soil at the hardware or at the lumber yard and mix it in with your clay to make it more productive to grow plants. That's what I mean by amending it. You simply add some stuff to it. Well, there's some cute little videos. But we better not take time. Arid soils represent the dry desert soils that often contain skeletons of sea creatures, which says what? They were once covered with water. These soil types work best for wildlife, ranges, and desert recreational activities. Unless irrigated and amended, enhanced to make them more useful for plants to grow in, where you add stuff to the soil to make it more beneficial for growing things, and water, because it doesn't retain water, so you have to irrigate it. But what does it say? If amended, these work. If amended, they unless they're irrigated and amended, they don't work for agricultural purposes. So if you want to take all the deserts of the world and make them productive, you're going to have to do two things. You're going to have to bring water, and you're also going to have to do something to build up the soil to make it more productive for producing plants. So that's what's going on here when they run through here and talk about each one of these. Soils in the yard or garden. Clay soils don't drain well. So, have you noticed in your yard where you have a place where the water seems to pool and it doesn't soak into the ground after it rains? Well, that probably means under that grass you've got a lot of clay soil that doesn't drain well. It just holds the water. Sandy soil is good for growing vegetables. Peaty soil is good for plants. Have you ever seen peat moss or peat you buy it in a bag at the store? Silty soil contains a lot of nutrients. Silt, it comes from the river. It's topsoil. Figure it out. If the topsoil that's really rich in nutrients gets washed down the stream into the river, then all of a sudden where it accumulates when the water slows down is where you'll get some nutrients. That's why, by the way, have you wondered why all these farmers are talking about, with all this flooding, my crops got flooded? And you say, well, why don't you plant your crops next to the river where they could get flooded? Because that's where all of the nutrients are that come from the river when it floods. And it makes for a good cropland, as long as it doesn't flood. So if you're going to farm next to a floodplain, what you have to count on is every few years you'll have a flood that washes it away. Does anyone know somebody who lives in western Kansas? Okay, now if you drive through western Kansas today, you'll often see the fields where they raise crops with a circle because they use irrigation. When they didn't have irrigation out there and they just did what they call dry land farming, people in western Kansas knew that about every 3 years you won't get enough rain for crops to grow. But you don't know which year it is, so you plant crops every year, knowing that about once every 3 or 4 or 5 years, you won't get a wheat crop. You won't get a crop from what you planted. That's just the price of living in western Kansas and doing business out there. And then, of course, once they found out that there was a huge reservoir of water underground, they started drilling wells and pumping the water out of there and growing crops that use a lot of water, i.e. corn, because it had a good price and they could make money on it. Well, does this surprise anybody? So many people in western Kansas and in Nebraska have started farming with this irrigation stuff, where it's pumping water out of the underwater reservoirs that, remember how we talked about the springs in Missouri, that they have to be replenished, or like the spring, Anna, you have on your farm, that you can't use it all because it doesn't have that much water in it? Well, does this surprise anybody? The wells they drill to get water out of it's called the Ogallala Aquifer. It has a Native American and Indian name, but they have to keep drilling the wells deeper and deeper and deeper. And someone asked the question, how deep can we go till we get to the bottom of the underground reservoir and there's no more water to pump out to irrigate our crops? Well, I guess we'll find out when we pump the reservoir dry. And western Kansas and western Nebraska will go back into dry land farming mode, where they don't raise corn anymore because it requires too much water, and they go back raising dry land crops like oats and barley and wheat, and they don't make as much money, but then they'll have a crop maybe every 3 out of 4 years, or 4 out of 5 years they'll have a crop, and 1 year they'll have such a drought they won't have a crop at all. If you have loamy soil, consider yourself lucky. Loamy soil is usually a mix of other soils, including sand, silt, and clay, has good nutrients and drainage, and it makes for lovely plant conditions. So, the little plants are a little picky about where they want to live and how they want to grow and be productive. And you know how you'll tell if you have real good soil? One of the best ways to tell is just plant some tomatoes. When tomato season comes in, go to the hardware store and buy some tomato plants and just plant them. I mean, you could plant them in different places in your yard, and the ones that have the best soil, does this surprise you, will produce the most tomatoes. And the ones that have the worst soil will produce very few tomatoes and sometimes none at all. So it talks about testing the soil here to see what kind of soil you have. There's just all kinds of cool stuff on here. I wonder, let me check to see. Did I put some of this soil stuff on CBC Geography? CBC Geography. There it is. Oh, Tom Bonine, CBC Geography Twitter. Does that just make you laugh? That makes my whole family laugh. And I still don't think, what's so funny about having a Twitter account? I don't know.
What does CBC stand for?
What?
What is
Calvary Bible College.
Oh.
This was before we were Calvary University.
Yep.
And when we changed to Calvary University, I was going to change the name. And somebody else was already using CU Geography, probably Colorado University or Cincinnati University. So I just had to leave it CBC.
It has a little ring to it. I like it.
But those of you who are going to be teachers, do you see where it would be to your advantage to start a Twitter account and start collecting geography stuff that you could use, and not just for geography, for all kinds of things? Let's see if I put something on here that has to do. Do I click yes?
Yes.
Or I won't get it, huh? Look at that cute little bird. What do we have here? Way too much stuff. Atmosphere biomes. Oh, that's one we want to look at. Those are biomes. Biomes, biomes, biomes. That's the next one. Can livestock grazing stop desertification or desertification? Can stop the desert from taking over the world? Some people think so. What happened there? I don't know. Yeah, people arguing about that. Types of soil. There we go. Let's click on that one and see what we have here. Is it going to come up? Do I have to sign in or something, or just click on it? Did I just lose it?
No, it's gone.
There. It just takes a while to get there. Types of soil and their uses. Oh, there it is, the 12 scientific soil types. There they are. Are there some pictures of them? That would be fun. Let's see if we can find some pictures. Let's go back and see if we can find some pictures of these soils. Well, maybe it's not going to go back. Well, then let's just shut it down. And let's go soil type pictures. Do we get anything? Soil type pictures. See what comes. Oh, cool. That's what I was looking for. Images of soil types. There you go. Sandy soil, see that? Silt soil. Tons of cool things. The 6 soil types. See, they go peaty, loamy, sandy, chalky, clay, and silty. They're talking about the kind that makes for a good garden. Whoa. Now that's some good looking soil. Who'd ever thought you could look at dirt and say that stuff looks so cool? Soil type makes a significant difference in the way trees grow and the way plants grow. Okay, I'll go back to that one. The dirt on Oregon wine. People who grow grapes to make wine, but you could also grow grapes just to eat them. The kind of soil you grow them in makes a difference in what the grapes taste like. I could sit here and look at soil types all day long. They're just so cool. And see how you can look at where they are on the globe? And what do we have a lot of here in the United States? Well, here in North America. A lot of what? Malleable soil and andisoil. Do you see that? From looking at the picture and then looking at the globe to see where it is. And do you notice in South America, Brazil has a lot of oxy soil, which isn't very productive. And Africa does too. And so does Australia. I mean, some countries just aren't. No, that's not oxy soil in Australia. That's what vertisoils. And every one of those different kinds of soil, you can look at them and read about them and study to see which ones are the most productive, or if you're going to go live somewhere, find out something about what you could plant there. I mean, it's pretty obvious that when I planted some plum trees and some peach trees in my garden, and all the trees have died and never did produce. I mean, when they did have fruit, they were just tiny little things, and now they've died. What does that tell you? That the soil where I planted them wasn't the kind that encourages the growth of plum trees and peach trees. Because if you eat plums and peaches, tree ripened, the ones you buy at the store don't taste good. So you might try to raise your own and find out that not here you won't, because they won't grow in your soil. That stuff I put up there about the desert, that's from page 136. And I'll just tell you, I mean, you can go to my Twitter account and click on some of that and read about it. But can you see why there would be a concern in the world about what can we do to stop the spread of desert regions that are not productive? And then is there some way we can take a desert region and reclaim it and make it productive? Does anyone know what country has probably mastered the art of taking desert land and making it productive? The nation of Israel. The nation of Israel has taken desert land, and they've learned how to add nutrients to the soil, and then they need water. So they've learned how to do what they call drip irrigation, that drips water right by each plant to give it just what it needs to grow. And the nation of Israel grows fruits and vegetables in such an abundance that they sell it to other parts of the world. And in fact, people in America have looked at the Israeli pattern and said, we need to, can you see where, if you go out to western Kansas or Nebraska, have you ever seen the irrigation things going to irrigate those crops? It's just big sprinklers spraying water up in the air where a lot of it evaporates. The people in Israel would say, oh no, you're wasting so much water. You would be so much better off if you would have little hoses running through your field and do drip irrigation. And the farmer would probably say, well, for raising corn, that's not going to work very well, so we'll just keep wasting water because we have lots of it. And hopefully, I mean, nobody knows for sure where all this water in the Ugalaga Aquifer comes from, but if a lot of it's coming from the mountains in Colorado, with all this rain, it could be that that reservoir is going to start to build up and be restored, and the water's going to go up higher, and there'll be enough rain water collected to last for a few years, so it won't impact farming in western Kansas. But some guy who goes to western Kansas and pays big money for a farm to raise corn because he irrigates, can you see what happens if after he bought his farm 5 years later the water all dries up and his farm isn't worth anything now compared to what it was when he bought it? And then on page 136 it also not only talks about the desert, but it talks about soil fertility, and both natural and synthetic. What can you do naturally to make your soil more productive for plants? Do any of you mow grass? Okay, do you mulch your grass? Do you mow it with a mulcher so it just cuts it up real fine and stays on the yard? Or do you mow it and then rake it and have them haul the rake stuff off and take it somewhere? Both? See, I just mulch mine because if you mulch it fine enough, then what does it do? It turns back into more soil and makes the soil in my yard thicker, which will be more productive for grass growing. And some people say, no, I just rake the grass because I don't like it on my yard. It looks prettier. But then to give nutrients to my grass, I buy some fertilizer at the store and run it across my yard to make my grass greener and grow thicker. And my wife says, look at the neighbor's yard, how thick and green it is. I said, Nina, you know what he does for a living? He takes care of people's yards. So if you're going to hire him to take care of your yard, are you going to look at his yard to see what it looks like? I said, I don't want to pay him to take care of our yard, and I don't want to do all that work. And furthermore, if you fertilize it to make the grass grow, you just have to mow it more often. So let's just let nature run its course. I'll mulch the grass when I cut it, and we'll just let it do whatever it's going to do. And when my children say the yard looks bad, I'm going, well, if you want to do something about it, you can, but not me. I'm in the house busy looking for stuff for geography to add to my Twitter account. Why would I want to go out and work in the yard? So different kind of soils have different levels of fertility. And you'll find that out by just planting a garden in different places. On page 139, it shows a picture of cattle grazing. And actually, the land they're grazing on, well, here's what it says. 300 years ago, large herds of native grazers and newly introduced cattle could be supported on extensive grasslands. But today, only a few animals can be supported on these semi-arid environments. Now, two things have happened. That grassland doesn't get as much water as it used to get, but another thing has happened. If I put 10 cattle out on a big field and they get big and fat and I can sell them and make money with them, then what is my inclination? Then put 20 of them out there. Then put 40 of them out there. And have you figured out what happens if you put too many cattle out there? One time when I first moved into where I live, the pasture didn't look very healthy. So I bought some grass seed and bought one of these little things, little cranks that you turn and spread grass seed. And I walked all over my pasture planting grass seed. And the seed started growing and I had this lush green pasture. Just because I liked seeing a lush green pasture. And then my daughter called and said she had a friend who had some horses and wanted to know if her friend could keep her horses on our pasture for the winter so she wouldn't have to drive down in the country and check on them when the weather was bad. And I said, sure, why not? And I didn't know anything about this. I don't raise horses, but I think she put about 8 horses on 5 acres of grass. Anyone know what happened? They turned my pasture almost into a desert. They ate all the grass down. They ate all the trees that were growing in the fence. They ate everything. And finally, she had to start putting hay out there to feed them. And my pasture, that was lush with grass, became a feedlot. You know what I mean? Where it just didn't have hardly anything growing in it because the horses had eaten it down so much. And then, while they're walking around, they had, in the wet winter weather, they'd poked holes in the yard. So all of a sudden, oh, I guess I should tell you, I grew all that grass so I could turn my pasture into this beautiful baseball field. And I had this lush green baseball field in my pasture, and these horses destroyed it. Well, so much for doing a favor for your daughter. Fortunately, her friend sold her horses, so now I know better. Somebody says, can I keep horses on your pasture? No. Why not? Because it ruins my baseball field. Why do you have a baseball field? So my grandchildren can play baseball when they come to my house. That's why. So what? You don't use that pasture for anything productive? No. But if I wanted to, I could raise some goats or some sheep or some cattle, some chickens, and I could be a little self-sustaining farmer. But why would I do that when I can buy all that stuff at the grocery store? Okay, page 139 talks about ecosystems. You pronounce it any way you want. An ecosystem includes all the living organisms in an area and the physical environment with which they interact. An ecosystem can cover an area as small as a field or a pond. On any scale of analysis, large or small, certain fundamental elements exist. So what makes an ecosystem? Producers, that would be plants. Consumers, that would be animals to eat the plants. Decomposers, that would be the little worms in the soil and the bacteria that decompose. And abiotic materials and energy necessary for production and consumption to occur. And that would be water, mineral nutrients, gases, and sunlight. So there you go. Page 140 shows a picture of a little ecosystem. And have you figured out what's going on here? Probably the first thing you notice is that little coyote on his way to consume that little rabbit. And that little rabbit had been consuming the grass, but now he's gone because the coyote ate him. And what the coyote didn't eat decomposes and puts nutrients back in the soil. And the heat from the sun accelerates the decomposition process. And carbon dioxide and oxygen and nitrogen and minerals go into the air and then come back through plants into the soil. And then where are you on the food chain? You go, what do you mean? Okay, obviously the rabbit is on the coyote's food chain. You understand that? That the coyote eats rabbits. So who eats coyotes? You know, I guess nobody. So he's the main man on the food chain. No, there's somebody bigger than him out there. So where are you in the food chain? Let's see, what animals do you consume? Chickens, fish, beef, pork, lamb, goat. You know, I don't think I eat goat. Well, you ought to try it. It's pretty tasty stuff. Have you ever heard someone tell you about some bizarre meat you could eat tastes like chicken? Yeah. Every time they tell me that, I say, then I'll just order chicken, and we'll both be happy. Because some of these bizarre meats out there. Have any of you ever eaten escargot?
A what?
Escargot. E-S-C-A-R-G-O-T.
Snails.
Well, if you go to a fancy restaurant, you can order it. You know what escargot is?
Snails.
Snails.
Yeah.
I said to a friend of mine who ordered it one time, I'm sorry, but if you're going to buy snails, just why don't they put snails in the menu? I mean, they don't take beef and chicken and give it some exotic name, do they? There's some reason for that. And that's because I'm not eating them. Yes?
They actually gave beef a fancy name.
What?
They actually gave beef.
They gave beef a fancy name?
Which is a steak.
So it's a steak. Yeah, it's a steak. Yeah, I got a steak. Eat some steak. So, where are you on the food chain? You say, okay, I eat meat, fish, poultry, wild duck. No, you say, I don't eat wild duck. Why not? Well, ducks are so pretty, I just don't want to eat them. Well, you don't eat the pretty part. You just eat the meat that's left after you pull the pretty feathers out. Oh, you say, I'm not going to eat any meat at all? Poor little critters. I'm just going to eat plants.
There's something wrong if you do that.
And you know what I say to my vegetarian friends? Why would you do that to a poor little carrot? I mean, little carrot's minding his own business, just growing in the soil, and you pull him up and chop him up and eat him? How disgusting. I mean, if they're going to say that about me eating a chicken, why can't I say that about them eating a carrot? I mean, if you want to just eat carrots and lettuce and tomatoes and celery, go ahead. But those plants feed animals, and then animals work up the chain. The ones that puzzle me in the ocean is these huge big whales that have a great big mouth. Do they have that big mouth so they can eat sharks? No, they eat these tiny little things. They just eat tons of them because they're so big. So that's what the cycle looks like. And over here on page 141 is a picture of plants and animals, and shows a carnivore, a herbivore. Have you figured out what a herbivore is? They don't eat other animals, they eat plants. A carnivore eats other animals. So, are you a carnivore, a herbivore, or
Omnivore.
Omnivore, which means you eat anything. If it tastes good, eat it. Until you get old, and then your doctor says that your cholesterol's bad, and this is bad, and that's bad. And I'm getting said, so what am I supposed to do about it, doc? That's just the price of getting old. And he says, you need to change the way you eat. And I said, like, tell me what it is I need to quit eating. And he gave me a list of all my favorite foods. And I just said, you know, I have to be honest with you. If that's what I have to do to stay alive, I'm looking forward to going to heaven. So why would I postpone a marvelous destination just because you say I can't have biscuits and gravy anymore? And my family gets all worked up about it. And I'm going, hey, you guys, I mean, if I ate the way my doctor suggested, here's what it would be the rule. If it tastes good, spit it out. If it tastes like cardboard or plastic, go ahead and eat it. It has to be good for you. I'm sorry, but I'm just going to keep enjoying the bounty of God's provision till it's my appointed time to go to heaven. Okay, on page 143 it talks about biomes. I had some of those up there, so let's go back to CBC geography. Yeah, let's just erase this and see if we can get back up there. How we doing time-wise, okay? I think we're going to be okay. CBC geography.
Back about
Uh-huh.
a
I don't have it turned on, do I? I appreciate you guys helping me keep that straight. Do you want to switch apps? Yeah, I have to. Thank you, class, for helping me learn how to use this machine. Biomes. Yeah. This is cool. What's that? Well, let's go back. Am I doing something wrong? Should I just be able to click on that and it takes off? Or do I have to put follow or something? I don't think I have to do that, do I? Okay, you know what I'll do? If it's not working like that, I'll just go back up here and go biomes. Biomes slideshow. Slide share. There it is.
Bless you. Thank you.
A biome is a major region that's characterized by its climate, soil types, and the dominant plants, animals, and other organisms that live there. A biome is made up of many individual ecosystems. So, where is it? Well, what in the world? It shows all these types, but where are the pictures? I think all those types are listed on the next page. Yeah, they are. Look at your globe again at page 144 and 145 and look to see where all of these biomes are. And the first one mentioned is tundra. And it says tundra, number 7, where it can be found. Number 8, Antarctica and the North Pole. Grass, lichen, and herbs. Permafrost, very short warm season that's very wet. Many insects during the warm season. And then it talks about the temperate deciduous forest. And the coniferous forest, conifers, evergreens, deciduous, they lose their leaves. Well, I thought I had pictures of this. What's going on here? Where are all the pictures? Okay, let's see what this does. I want to see the real pictures. Here we go. Okay, here's some. There's the desert. I guess you knew that already, didn't you? What's another one here? What's this one? A taiga biome. Tropical rainforest. There we go. Let's try this one. Freshwater, marine, wetland, desert, forest, grassland, tundra. So you can find pictures. They have some pictures of them here as to what they look like. And they also have definitions. But it also, you can go to the internet and find more information about them. On page 144, just to show you, under forest biomes, we grouped forest biomes into 4 categories. Tropical rainforest, mid-latitude broadleaf deciduous forest, needle leaf or boreal forest, and temperate rainforest. So see, the guys who make up these, just like the guys who study soils, they go, whoa, there are so many kinds of soils, and they come up with these names and these descriptions for them. Well, then people who study biomes do the same thing. So can you see where every one of these topics could be a complete course in itself if you were that inclined to go that much in depth? I mean, wouldn't it be fun to take a course where we study the biomes of the world and all we do is spend our time flying from one biome to another, walking through it, learning about it off of our tablets? Someday, that might be the way we study stuff like this. But for now, we buy a book, we read about it, we go to the internet, we look at pictures. That's the best we can do. But there's some cool stuff out there. Have any of you been in some of these biomes that are mentioned here? Okay, look at the North America and look at the colors there. Like, what's that brown? Where is that brown on your globe? Get your little globe, and on page 144, look at North America and kind of put your fingers where that brown area is, right in there. Okay? Where am I? It looks like I'm kind of east of the Rocky Mountains. And do you notice on your globe that all those little rivers start up there in that area and then flow down toward the Mississippi River, or flow down into Texas, or flow down into New Mexico and Arizona? If all those rivers are going from there, do you get the notion that that's pretty flat land right in there? And then as you go north and you see that it talks about the Rocky Mountains, then you say all of those rivers are running east of the Rocky Mountains into the Mississippi River. We've looked at that before. So you see this area here, you say, that's that color brown. What is that? What do they call that on this chart here?
Short grass.
Short grass. Have you ever driven through the short grass? Have any of you gone out to the Flint Hills? And now I go through the Flint Hills when I go to Oklahoma to see my relatives. But have you ever taken an exit off of the interstate in the Flint Hills and then driven on one of those gravel roads through the Flint Hills? Have you done that, Celeste?
I don't remember. Probably. Yes.
Well, can you imagine that I wanted my children to see things like that when they were younger? Even though they wanted to get on down and see their grandparents. And I would take these little diversions. And I remember one of them I took into the Flint Hills. We're driving down this gravel road, and my wife is, Tom, are you sure this is a real road or is this somebody's driveway? I said, it's a real county road. She goes, where does it go? I said, it goes to nowhere. It's just a road that ranchers use out here to get from one little town to the other. And the road was almost like, eventually got to a place where it was like two little ruts with grass growing in between. And all of a sudden, we're driving along and I hear this beep hitting the windshield. And I said, girls, do not roll the windows down. We had run into a nest of hornets and they were attacking my car. What would have happened if we would have been out riding horses or hiking down this trail? We could have easily been stung to death by all of these hornets. I mean, they were so mad, they were crashing into my windshield and killing themselves, trying to get at us. Have any of you been through a desert? No desert travelers here? You have?
Mm-hmm.
Which desert?
Death Valley.
Death Valley?
Mm-hmm.
And did you take plenty of water with you?
Yeah.
Because you know what happens to a lot of people? They go to death and they say, hey, I feel okay. They don't realize that the reason they're not sweating is because it's so hot and dry, the moisture just evaporates before it can form water on you. But if you don't keep drinking water, you'll get dehydrated and then get disoriented and wander off someplace and die. Have any of you been, okay, so you've been out into the desert. Which color is that here? There it is. That sandy color, warm desert. Get your globe and see where that the dark brown, and then there's the green with the desert area in there. There's the desert area right out that way. It looks like what, around Las Vegas and Phoenix and down in there. So what's that bright green? What's that green area that's up there in the northwest part of the United States? It's not tropical rainforest. That's a lighter blue. What's it called on the chart there on page 144? That dark green area that's got some brown in the middle of it. Needle leaf or boreal forest. Have any of you been to the boreal forest? Well, I have. Mount St. Helens erupted. Do you remember when that happened? Blew the side off of that mountain, just buried a lake, and blew trees 30 miles away, broke them like toothpicks. And I went out there just to see what it looked like. I wanted to look at it after 5 years after it had happened. And while I was there, I drove up into the northwest, and I'm driving through this boreal forest area where the trees are just huge. I got out and put my hands like this around a tree, and I would have to do that. Think about this, a tree so big that I would have to do this 3 times to reach all the way around the tree. I had never in all of my life seen a tree that big.
In Gambia, there's a tree that's like almost the largest in the world, I think.
That grows like that?
Yeah, it's really like knobby and quick twisted, but it's huge.
I was just, and these things are tall. It's like, well, why do these trees grow so big? Because of the climate, because of the biome, because of all the moisture they get, and the nutrients they have. So it's like, wow. And so then I'm thinking, this is so cool. So I got out and wrapped my arms around this tree and went around it about 3 times to see how big it was. And I go, wow, this is something. And I get back in the car and I have allergies. And all of a sudden, my nose starts running and I go, man, what's going on? But see, it's so humid out there. There's a lot of mold in the air and even growing on the trees. Does anyone have allergies and know what mold does to people with allergies? I couldn't believe it. My throat started closing up and I could hardly get a breath. And that's scary. And I rolled the windows up on the car and turned on the air conditioning to get all the pollen out of there and said, we are getting out of this forest. I couldn't believe that. And so can you see now, okay, I've been to a boreal forest and think that's really cool. Wouldn't it be fun to go to a tropical forest? Yeah, well, Tom, you take off hiking in the tropical forest and you run into all that mold and stuff. And by the time you can turn around and get out of there, you're dead. You're toast. So with your allergies, you better just stick to looking at pictures to see what they look like. And I see them here on the screen on my computer, and then I see them over there, and they don't look near as pretty there as they do here on this screen. The colors are much more vivid. So basically, get your computer and go look at some of this stuff. to see what it looks like, just to become aware of what's going on. Page 146 shows a picture of canopy layers in a forest. Have any of you been to a forest? Okay, a tropical forest. You have? Okay, I haven't, and I probably never will, but I love looking at pictures of it. This to me is amazing. There are scientists who have people take them in by helicopter, and they drop nets in the top of the trees. And these guys are way up above the ground, sitting on these nets, studying the biome, or actually studying the ecosystem that exists in the top of the tropical forest. There's a whole ecosystem of plants and animals that just thrive up there. Then there's another guy on the ground saying, guess what? In this biome, there's another ecosystem down here on the ground of life cycles going on. And it's just, to me, it's just intriguing to realize that God created all of this stuff. In fact, we still keep discovering new species of animals and plants that we didn't know existed. And every now and then, when I'm doing this geography research, I come across something where, oh, look, they thought this animal was extinct, and they just found one somewhere, and now they're taking pictures of it. Bottom of page 146, I have to confess to you, I grew up in the short grass part of the world, in the Great Plains, where there were no trees, or if there was a tree, there's only 2 or 3 of them. On my grandfather's farm, I remember he had one tree, a pear tree. On the other grandfather's farm, he had a big cottonwood tree. And other than that, there might be a few little trees growing somewhere, but they weren't enough to amount to much. When I first moved to Missouri and saw all of these trees around here, I felt claustrophobic, like I was being closed in on, because I wanted to go take a drive out into western Kansas where you can see for miles and miles of open space. And people who grew up here when I came to Calvary and who had grown up here with all these trees, they go, I drove through Kansas. It's just miles and miles of nothing. I'm going, nothing? It's beautiful out there. And these trees give me claustrophobia. Now, I've lived here in Missouri long enough to where now I go driving through this when the leaves change color because it's so beautiful. And when I go to Oklahoma to see my family, I don't tell them this, but when I go to Oklahoma to visit my relatives, on my way back, I sometimes head east to get to Arkansas where the trees are, because it's so much prettier than driving through the Flint Hills.
Amen, brother.
I mean, it's just, I've developed a new appreciation. But actually what happens, I think I have an appreciation for both, and it might not hurt to try to gain some appreciation for all of these different kinds of climates and biomes that God has created in His world. I've never walked on a glacier, but from the pictures I've seen of it, I'm not too interested in doing that. And I've never gone to either one of the poles. And from the way people bundle up to go there, I'm not too interested in doing that. But it would be kind of fun to hike down part of the Appalachian Trail. And I did go one time clear up into Canada just to see what it was like on the other side. Wow. They're not mosquitoes because they don't bite you, but they have something up there that's way too big for a flying insect. They crash into your car.
Did you know termites fly?
What?
Termites fly.
Yes, that's disgusting,
I hate flying
isn't it?
termites.
But I will tell you, the Grand Canyon, beautiful. Niagara Falls. I mean, if you get a chance to look at some of this stuff, take some time, can I say this, to enjoy some of the beauty of what God has made. On page 148, it talks about savanna, scrublands, and open woodland biomes. And there you go. That picture on page 149, see, that just reminds me of home. One tree out there and a whole bunch of grassland. And what did people do with that grassland? They decided that they could make more money rather than raising cattle on the grassland. They could make more money by plowing up the grassland and planting crops. And in Oklahoma, in western Oklahoma and northeastern Texas, or northern Texas and southwestern Kansas, they plowed up so much of that grassland that sure enough, they had a drought, and the drought created the Dust Bowl. Have any of you ever seen pictures or documentaries on the Dust Bowl? The wind was blowing dirt and it was drifting up against a fence like snow does up in Wisconsin and Minnesota. Because what happened is, when it was grassland, the grass was holding the soil there. So when the drought came, the roots were deep enough to keep the grass alive. When the wind came, then all it did was just blow the grass around. Once they plowed all the grass up and they were raising wheat, which has this tiny little root system, that it just blew the wheat away, blew the root system, blew the topsoil away, and just turned it into nothing. And the people out in the area where they had the Dust Bowl during that drought years and years ago, those people who kept raising cattle on grassland, the Dust Bowl didn't bother them at all. But all of their neighbors who plowed their land up to raise wheat, because the world was buying wheat and it was a good cash crop, their farms basically blew away. Now, since then, we've discovered ways to restore the land and rebuild it and get back to using it, and they've changed their farming techniques, so if we have another drought and another big windstorm like that, it won't blow it all away like it did before. But basically, sometimes man, and I think it's fair to say this, he gets to be a little too greedy, and he does some things that result in serious damage happening to the world that God put us in. And I happen to believe that God put enough natural resources here for us to live life in a way that pleases Him until He's finished with this earth and He decides that time is over and He's going to build a new heaven and a new earth. But if we keep being too greedy about stuff, we're probably going to use up a lot of these natural resources earlier than what He intended. Okay, that's the end of this chapter, and we're out of time. And look some stuff up on the internet, and be sure and get your assignments done. I'm not going to talk about them, just go. I'll send out announcements once in a while, but if you got zeros on your assignments, once you get them done, I'll change your grades. I'll just penalize you a few points for your work being late.